Right now, as you sit here, every person you have ever loved, every hospital that could save your life, every voice that could answer your call exists on one single point of light. Step far enough away from the sun, and that point vanishes, not metaphorically, physically. The signal from Earth becomes too faint to detect. A rescue mission would take longer than your natural lifespan. A distress call would arrive centuries after you are already dead. Beyond the solar system, Earth does not stop being precious. It stops being useful. It stops being reachable. It becomes a memory that cannot protect you, a home that cannot hear you, and an origin that cannot save you. That is not poetry. That is physics. And it is one of the most unsettling truths humanity will ever face. If this is the kind of deep science storytelling you appreciate, consider hitting like and subscribe. We do not chase trends here. We chase the questions that actually reshape how you see reality. Are you comfortable? Now, let's begin. Every morning, roughly 8 billion people wake up on the same planet. They open their eyes in different time zones, under different skies, speaking different languages. But every single one of them shares an assumption so deep it never even registers as a belief. Earth is the center, not the center of the universe. Most people gave up that idea centuries ago. The center of meaning, the place where everything that matters happens. The place that matters to everything that happens. It is where food comes from, where hospitals operate, where governments make decisions, where someone will come looking for you if you disappear. It is where rescue exists, where communication is instant, where you are never truly alone because somewhere on that surface someone knows your name and could theoretically reach you within hours. That assumption is not wrong. Inside the world humans have built, it is perfectly accurate. Earth is the center of every system we depend on. The problem is that this assumption has a range. And the range is not infinite. It is not even close to infinite. It has a boundary, a real physical boundary, beyond which every single thing that makes Earth your center stops functioning. Beyond that boundary, Earth does not stop existing. It does not stop being the place where your species evolved, where your family lives, where your memories were formed. It stops being the place that can do anything for you. That is a different kind of loss, and almost no one has ever had to think about it seriously because almost no one has ever approached the edge. To understand how deeply this illusion runs, consider where you are right now. You are sitting on the surface of a rocky planet, orbiting a middle-aged star, roughly 26,000 light-years from the center of the Milky Way galaxy. The planet is spinning at roughly 1,000 miles per hour at the equator. It is orbiting the Sun at roughly 67,000 miles per hour. The entire solar system is moving through the galaxy at roughly 486,000 miles per hour. You feel none of this. The ground beneath your feet feels solid, stable, permanent. The sky looks the same today as it did yesterday. The stars appear fixed. Everything in your sensory experience tells you that you are stationary and the universe is a backdrop, a painted ceiling above a room that belongs to you. This is not a failure of intelligence. It is a feature of biology. Human beings evolved on this surface. Every instinct, every reflex, every cognitive shortcut your brain uses to navigate reality was calibrated to conditions on Earth. Gravity feels normal because your bones grew under it. The atmosphere feels breathable because your lungs adapted to it. Distances feel manageable because your legs were built for this terrain. The entire architecture of human perception is an Earth-based system. And like any system, it works flawlessly inside its design parameters and collapses the moment you take it outside them. For most of human history, that was not a problem. The farthest anyone could travel was the other side of the planet, and even that took months. Earth was not just the center, it was the entirety of the accessible universe. Every horizon led to more Earth. Every ocean connected to more coastline. There was nowhere you could go where the planet itself could not sustain you, where the air was not breathable, where the ground was not solid, where home was not theoretically reachable by turning around and walking long enough. Then we left. On October 4th, 1957, a small metal sphere called Sputnik crossed above the atmosphere and entered orbit. It did not go far. Low Earth orbit is roughly 250 miles above the surface. If you could drive a car straight up at highway speed, you would be there in under 4 hours. Sputnik was still firmly inside Earth's gravitational grip, circling the planet every 96 minutes, closer to the surface than most people drive in a single road trip. But symbolically, something had changed. For the first time in 4.5 billion years, an object made by a living species on this planet had left the atmosphere. The ceiling had been punctured. The room was open. Within 12 years, human beings followed. On July 20th, 1969, Neil Armstrong and Buzz Aldrin stood on the surface of the Moon, roughly 240,000 miles from Earth. At that distance, communication delay was barely noticeable, about 1.3 seconds each way. Mission Control in Houston could speak to the astronauts and hear a reply within 3 seconds. If something went wrong, engineers on the ground could react almost in real time. The Earth filled a portion of the lunar sky, a blue and white marble hanging in the blackness, visually dominant, emotionally overwhelming, and practically accessible. The trip home took about 3 days. Apollo 13 proved this in the most dramatic way possible. When an oxygen tank exploded halfway to the Moon, the crew was in mortal danger. But Earth was close enough that Mission Control could walk them through emergency procedures in near real time. Engineers on the ground designed improvised carbon dioxide filters using materials the crew had on board, talked them through the construction step by step, and guided them around the Moon and back to a safe splashdown in the Pacific Ocean. The rescue took days, not decades. Communication was measured in seconds, not years. Earth was right there. Close enough to help, close enough to save them. That mission became the defining story of human spaceflight, and for good reason. It proved that even when things go catastrophically wrong in space, Earth can reach you. Home is not just an emotional concept, it is an operational lifeline. A real, functioning source of expertise, guidance, and intervention that can cross the distance and pull you back from the edge. Every crewed space mission since Apollo has operated under this same fundamental assumption. The International Space Station orbits at roughly 250 miles. Communication delay is negligible. Resupply ships arrive within days. Emergency evacuation to Earth takes hours. Astronauts aboard the station can video call their families, watch live television, receive medical consultations from doctors sitting in offices on the ground. The tether to Earth is short, strong, and constantly active. They are in space, but they are not away from Earth in any meaningful operational sense. Earth is still doing everything for them, providing oxygen recycling technology designed and built on the surface, providing food launched from the surface, providing mission plans, psychological support, and emergency protocols developed by teams sitting in buildings with gravity under their feet. Now, stretch that tether further. Mars, at its closest approach, is roughly 34 million miles from Earth. At its farthest, the distance exceeds 250 million miles. Communication delay varies between roughly 3 minutes and 22 minutes each way. That means a round-trip conversation takes between 8 and 48 minutes. If something goes wrong on a crewed Mars mission, the crew cannot call Houston and wait for instructions in real time. They will send a message describing the emergency. Then they will sit in silence for up to 24 minutes while the signal crawls across the void at the speed of light. Then Mission Control will receive the message, assess it, formulate a response, and transmit it back. Another 24 minutes of silence. By the time the crew hears the reply, nearly an hour may have passed since the emergency began. In many survival scenarios, an hour is far too long. The crew will have to handle the crisis themselves, using their own training, their own judgment, their own resources. Earth will still be there. Earth will still be trying to help. But the help will arrive late. The tether is stretching. Now, go further still. Jupiter orbits at roughly 484 million miles from the Sun. Communication delay at that distance is roughly 33 to 53 minutes each way. Saturn is roughly 886 million miles out. One-way signal time approaches 80 minutes. Uranus is roughly 1.8 billion miles away. Neptune is roughly 2.8 billion miles. At Neptune, a message from Earth takes over 4 hours to arrive. A round-trip exchange takes more than 8 hours. You could send a distress call in the morning and not hear a response until the evening. The help Earth offers at that distance is no longer intervention. It is commentary. Delayed, detached, arriving after decisions have already been made and consequences have already unfolded. But even at Neptune, Earth is still technically reachable. The Voyager missions proved this. Voyager 2 flew past Neptune in August of 1989, returning stunning images and data from the planet's atmosphere, rings, and moons. The data traveled back to Earth at the speed of light, received by the Deep Space Network, a collection of massive radio antennas positioned around the globe in California, Spain, and Australia. The signal was faint but detectable. The connection was slow but real. Earth was still listening. Earth could still hear. As of today, Voyager 1 is the most distant human-made object in existence. It is roughly 165 astronomical units from Earth. 1 astronomical unit is the distance from Earth to the Sun, roughly 93 million miles. So, Voyager 1 is over 15 billion miles away. The signal it transmits operates at roughly 22 watts, about the power of a refrigerator light bulb. That signal, spreading out across 15 billion miles of empty space, arrives at the Deep Space Network as a whisper so faint that the energy received is roughly 20 billion times weaker than what a digital wristwatch uses to power its display. The Deep Space Network can still detect it. Barely. The dishes used to receive Voyager's signal are 230 feet across, among the largest and most sensitive radio antennas on Earth. They were built specifically for this kind of work, designed to pull meaning out of the faintest possible signal, crossing the deepest possible distances within the solar system. And they are reaching their limits. Voyager 1's signal takes over 22 hours to reach Earth. A round-trip communication takes nearly 2 full days. The spacecraft's power supply, fueled by the radioactive decay of plutonium-238, is declining steadily. By the mid-2030s, it will no longer generate enough electricity to power any scientific instruments. The signal will go silent. Earth will lose contact permanently with the farthest object it has ever built. But here is the crucial detail. Voyager 1 is still inside the Sun's sphere of influence in the broadest gravitational sense. It crossed the heliopause in August of 2012, entering interstellar space by one important definition. The heliopause is the boundary where the solar wind, the constant stream of charged particles flowing outward from the Sun, is no longer strong enough to push back against the incoming particles from the interstellar medium. Beyond this line, you are no longer surrounded by material that came from your star. You are surrounded by material that came from everywhere else. Voyager crossed that line. It is now traveling through interstellar space, but it has not escaped the Sun's gravity. The Sun's gravitational influence extends outward to roughly 1 to 2 light-years, defining a vast spherical region called the Oort cloud, a shell of trillions of icy bodies loosely bound to the Sun by the thinnest gravitational thread. Voyager 1, at roughly 165 astronomical units, has not even reached the inner edge of the Oort cloud. The inner boundary is estimated to begin somewhere between 2,000 and 5,000 astronomical units. The outer edge may extend to 100,000 astronomical units or more. At Voyager's current speed of roughly 38,000 miles per hour, it will take roughly 500 years to reach the inner Oort cloud and perhaps 300,000 years to pass through it entirely. That means the farthest human-made object, traveling for nearly 50 years, has not even left the Sun's front porch. And yet, at this distance, Earth is already fading as a practical resource. The signal is almost undetectable. The communication delay is nearly 2 days. No rescue mission could reach Voyager in any human lifetime. The spacecraft is operating on stored instructions, executing commands uploaded months in advance, drifting on momentum imparted decades ago. Earth still knows where Voyager is. Earth still receives its faint signal. But Earth cannot meaningfully intervene in anything that happens to it. If a micrometeorite struck a critical component tomorrow, Earth would learn about the damage 22 hours later and could do absolutely nothing about it. This is the state of affairs at roughly 165 astronomical units. Still inside the solar system by any gravitational definition, still within the region where the Sun is the dominant star, where the Sun's gravity governs motion, where Earth's origin point remains identifiable as the center of the system. And already, Earth is functionally powerless. Now consider the heliosphere as a whole. Inside this boundary, conditions are governed by the Sun. The solar wind fills the space between planets with charged particles. The Sun's magnetic field extends outward, creating a protective bubble that partially shields the inner system from galactic cosmic rays. Planets orbit in stable, predictable paths. Distances, while enormous by human standards, are at least expressible in terms that the human mind can process with effort. The Earth-to-Sun distance gives us the astronomical unit. The outer planets are tens of astronomical units away. The heliosphere extends to roughly 120 astronomical units in the direction Voyager 1 traveled. Inside this bubble, Earth-based systems still function. The Deep Space Network can communicate with probes throughout the heliosphere. Navigation is referenced to Earth-based coordinate systems. Mission planning originates from institutions on Earth. Scientific analysis is performed by researchers sitting at desks in universities and laboratories on the surface. The Sun is always the brightest object in the sky from any point inside the heliosphere. Earth is always locatable, always identifiable, always the point of origin. The heliosphere is, in a very real sense, the operational range of Earth's relevance. Inside it, Earth can speak to its machines, can guide its missions, can monitor conditions, can maintain a connection, however tenuous. The heliosphere is not Earth's atmosphere. It is not Earth's gravity well. But it is the region of space where being from Earth still means something practical, where the systems, institutions, and infrastructure of human civilization can still reach, however slowly and faintly. What happens when you leave it is a different kind of story entirely. The New Horizons spacecraft, which flew past Pluto in July of 2015 and later visited the Kuiper Belt object Arrokoth, is currently over 60 astronomical units from Earth, heading outward at roughly 36,000 miles per hour. It will eventually cross the heliopause and enter interstellar space, following Voyager's path into the void between stars. When it does, it will carry with it the same set of stored instructions, the same declining power supply, the same fading signal. And like Voyager, it will cross a line beyond which Earth's ability to support it drops from minimal to essentially zero. But both Voyager and New Horizons are machines. They do not need rescue. They do not need food, warmth, or medical care. They do not experience loneliness. They do not understand what it means to be beyond help. They execute their programming until the power runs out, and then they drift forever, silent, cold, indifferent to their own distance from home. A human being is not a machine. A human being crossing the heliopause would carry with them every biological vulnerability, every psychological need, every emotional dependency that evolution built into the species over millions of years on a planet where help was never more than a walk away. They would carry the expectation, buried so deep it feels like instinct, that somewhere behind them, someone is watching, someone is listening, someone could come. And for the first time in the history of the species, that expectation would be wrong. Not wrong because Earth stopped caring. Not wrong because the mission was abandoned, or the funding was cut, or the political will collapsed. Wrong because physics does not negotiate. Wrong because the speed of light is not a suggestion. Wrong because the distance between stars is not a number on a page, but a physical reality, so vast that every human system designed to protect, support, and rescue breaks down completely before you have crossed even a tiny fraction of it. Inside the solar system, Earth is the center. It is the origin of every mission, the destination of every return, the anchor of every coordinate system, the source of every voice on the radio. It is home not just emotionally, but operationally. It is the place that can hear you, help you, and bring you back. The question this story is about to answer is what happens to all of that when you leave. Not when you leave Earth's surface. Not when you leave Earth's orbit. Not when you leave the neighborhood of the outer planets. When you leave the solar system entirely and enter the space between stars, where the sun is just another dot in the sky and Earth is not visible at all. What changes is not how you feel about home. What changes is what home can do for you. And the answer, once you see it clearly, is one of the most quietly devastating truths in all of science. The tether does not snap. It does not get cut. It stretches, thins, weakens, and fades until you are holding a thread so fine that it carries nothing but memory. Earth is still there. Earth is still turning. 8 billion people are still waking up every morning under the same sky, living their lives, assuming they are at the center of everything that matters. And they are right. For them, inside their world, on their surface, Earth is the center. But for you, out beyond the heliosphere, falling into the space between suns, that center has lost its gravity. Not the gravity of physics, the gravity of relevance, the gravity of immediate, practical, life-sustaining connection. That loss does not begin all at once. It builds, it accumulates. It follows a curve that starts so gradually you barely notice it and ends so steeply that by the time you understand what has happened, the transformation is already complete. And the first thing to collapse, the first system to fail across interstellar distance, is the one humans depend on most: the ability to be heard. The Deep Space Network is the most sensitive ear humanity has ever built. 3 complexes positioned roughly 120 degrees apart around the globe, in Goldstone, California, near Madrid, Spain, and near Canberra, Australia, ensure that no matter how Earth rotates, At least one giant antenna is always facing any given point in the sky. The largest dishes are 70 meters across, 230 feet of precision-engineered steel and aluminum, cooled to cryogenic temperatures at their receiver cores to minimize electronic noise. These instruments were designed to do one thing extraordinarily well: detect signals so faint that they arrive carrying less energy than a snowflake landing on a frozen lake. Right now, the Deep Space Network maintains contact with every active mission in the solar system. It talks to spacecraft orbiting Mars. It communicates with probes studying Jupiter and Saturn. It receives data from missions mapping the Sun's magnetic field. And at the extreme edge of its capability, it picks up the whisper from Voyager 1 more than 15 billion miles away. That whisper arrives at a power level measured in units so small they strain comprehension. The signal Voyager 1 delivers to a 70-meter dish on Earth carries roughly 10 to the negative 16th watts. Written out, that is 0.000000000000001 watts. To detect that, the Deep Space Network must distinguish it from the background noise of the universe itself, the constant hiss of cosmic microwave radiation, the crackle of distant quasars, the electromagnetic chatter of Earth's own civilization bleeding into the receivers. To understand how extraordinary that detection is, consider an analogy built entirely on scale. Imagine standing in Sydney, Australia, and someone in New York City lights a single birthday candle. Not a floodlight, not a bonfire. A single small candle, the kind you press into a cake for a child's party. The distance between those two cities is roughly 10,000 miles. The light from that candle, spreading outward in all directions, would be so diluted by the time it reached Sydney that no human eye could detect it. No ordinary camera could capture it. You would need specialized astronomical equipment just to confirm the photon existed. That is roughly the challenge the Deep Space Network faces when listening to Voyager 1. A signal weaker than the dimmest household nightlight, crossing 15 billion miles of vacuum, arriving as a trickle of energy so sparse that only the most sensitive instruments on the planet can pull it from the noise. Now take that candle in New York and move it further. Do not move it to another city. Move it to the moon. The light is now crossing 240,000 miles instead of 10,000. The inverse square law punishes the signal immediately. The intensity drops by a factor of over 500. The candle that was already undetectable from Sydney is now undetectable from anywhere on Earth, without equipment specifically designed to find it. Now, move the candle to Mars. 140 million miles at closest approach. The signal drops by a factor that runs into the trillions compared to the original 10,000-mile baseline. You are no longer looking for a dim flicker. You are looking for a mathematical ghost, a quantity so small that it exists more as a concept than a measurement. Now move it to Proxima Centauri, 25 trillion miles. The candle is the same candle. It has not changed. It is still burning with the same small flame, emitting the same modest number of photons per second. But those photons are now spread across a sphere so vast that the surface area is measured in numbers that have no physical referent in human experience. The energy arriving at any point on that sphere is not small. It is essentially zero, not approaching zero, not trending towards zero, for all practical purposes, indistinguishable from zero. That is what the inverse square law does to communication across interstellar distance. It does not weaken signals the way fog weakens a headlight, where you can still see something if you squint hard enough. It annihilates them. It spreads the energy so thin across so much space that the original signal, no matter how powerful it was at the source, becomes a quantity that no instrument can meaningfully recover. The signal does not fade into the distance. It is devoured by it. Consumed by the geometry of three-dimensional space, expanding in every direction simultaneously, each additional mile of distance stealing energy not linearly but quadratically, accelerating the loss with a mathematical ruthlessness that no amount of engineering can fully overcome. This is not a poetic way of saying that communication gets harder. It is a physical description of why communication eventually becomes impossible. The universe does not block the signal. It does not jam it or interfere with it. It simply provides so much space for the signal to spread into that the energy per unit area drops below the threshold where any receiver, no matter how sensitive, can distinguish it from the thermal noise of its own components. The signal is still there, technically. Every photon Voyager ever transmitted is still traveling outward at the speed of light, spreading across an ever-expanding sphere. But being there and being detectable are not the same thing. A single molecule of water is still water. But a single molecule of water spread across the surface of a lake is not a drink. It manages this because Voyager 1 is still relatively close. Roughly 165 astronomical units is an almost incomprehensible distance by any human standard. It is over 15 billion miles. Light takes more than 22 hours to cross it. But, in the language of interstellar space, it is nothing. It is a single step outside the front door of a house, sitting on a continent that stretches for thousands of miles in every direction. The nearest star to the Sun is Proxima Centauri, a small red dwarf sitting roughly 4.24 light-years away. 1 light-year is approximately 5.88 trillion miles. 4.24 light-years is roughly 25 trillion miles. Voyager 1, the farthest human object in existence, has covered roughly 15 billion of those 25 trillion miles. It has completed approximately 0.06% of the journey to the nearest star. At its current speed, it would take roughly 73,000 years to reach Proxima Centauri if it were heading in that direction. It is not. Now consider what happens to a radio signal over that distance. Radio waves, like all electromagnetic radiation, obey the inverse square law. This is not a guideline or an approximation. It is a fundamental property of how energy spreads through three-dimensional space. When a signal travels outward from a source, it expands in a sphere. The surface area of that sphere increases with the square of the distance. The energy per unit area on that sphere decreases at the same rate. Double the distance, and the signal strength drops to 1/4. Triple the distance, and it drops to 1/9. Multiply the distance by 10, and the signal drops to 1/100. Voyager 1 is roughly 165 astronomical units from Earth. Proxima Centauri is roughly 268,000 astronomical units from Earth. That is roughly 1,644 times farther than Voyager. Apply the inverse square law, and a signal arriving from Proxima Centauri's distance would be roughly 2.7 million times fainter than Voyager's already almost undetectable whisper. Let that number settle. The Deep Space Network, the most sensitive listening system the human species has ever constructed, is already operating at the ragged edge of its capability to hear Voyager 1. A signal of the same power arriving from the distance of the nearest star would be nearly 3 million times weaker. It would not be faint, it would not be challenging, it would be invisible. The noise floor of the universe itself would bury it completely. No antenna on Earth, no matter how large, could extract meaning from it using current technology. This is not a temporary engineering limitation waiting to be solved by the next generation of hardware. It is a consequence of geometry. The inverse square law is not a technology problem. It is a property of space itself. You can build bigger antennas. You can use more sensitive receivers. You can cool your instruments to fractions of a degree above absolute zero. And all of these improvements will buy you distance, but the returns diminish brutally. To maintain Voyager-level signal quality at Proxima Centauri's distance, you would need either a transmitter millions of times more powerful than anything currently in space, or a receiving antenna with a collecting area millions of times larger than the 70-meter dishes of the Deep Space Network. Neither of these is physically impossible. Both are so far beyond current engineering that they belong in a category of ambition that does not have a schedule. This means that the first thing to collapse as you leave the solar system is the ability to communicate reliably with Earth. Not communication in the emotional sense, not the desire to speak or the longing to hear a familiar voice. The physical ability to send a signal strong enough to be detected across interstellar distance and receive one in return. The radio link that has sustained every human space mission in history, the invisible thread connecting every probe and every astronaut to the rooms full of engineers and scientists on the ground, does not stretch to the stars. It fades, weakens, and eventually dissolves into the background radiation of the cosmos long before you reach another sun. But suppose, for the sake of argument, that the engineering problem is solved. Suppose future technology produces transmitters powerful enough and receivers sensitive enough to maintain a communication link across 4 light years. What then? The signal still travels at the speed of light. Nothing travels faster. This is not a current limitation. It is a law of physics, confirmed by over a century of experimental evidence and woven into the structure of space-time itself. A message sent from a spacecraft at Proxima Centauri would take 4 years and 3 months to reach Earth. The reply would take another 4 years and 3 months to travel back. A single exchange, one question and one answer, would span 8.5 years. Picture the implications of that delay in human terms. An astronaut at Proxima Centauri discovers a medical emergency on board. A crew member has an injury requiring surgical expertise that no one on the ship possesses. They compose a detailed message describing the symptoms, the available equipment, the patient's condition. They transmit it toward Earth. Then they wait for 4 years and 3 months. During those 4 years, the patient either recovers, deteriorates, adapts, or dies. The message arrives at Earth. Physicians analyze it, consult specialists, prepare detailed instructions. They transmit the response. Another 4 years and 3 months pass. The surgical guidance arrives at the ship 8.5 years after the injury occurred. Whatever happened to the patient happened long ago. The advice is not late, it is archaeological. It is a message about a crisis that resolved itself, one way or another, nearly a decade before the help arrived. This is not an edge case. This is the baseline reality of interstellar communication at the shortest possible distance. Proxima Centauri is the closest star. Most stars in the galaxy are hundreds or thousands of light-years away. At a distance of 100 light-years, a single communication round trip takes 2 centuries. The people who sent the original message would be dead before the reply arrived. Their grandchildren might hear it. At 1,000 light-years, the round trip takes 2 millennia. The entire history of the Roman Empire, from founding to fall, fits inside a single exchange. The civilization that sent the message might not exist in recognizable form by the time the answer comes back. Communication delay at this scale does not degrade the connection between a traveler and Earth. It annihilates it. Communication is not just the transmission of information. It is the exchange of information within a time frame that allows it to influence decisions, alter outcomes, coordinate actions. A weather forecast that arrives a year after the storm is not a forecast. A warning that arrives a century after the danger has passed is not a warning. And guidance from mission control that arrives a decade after the crisis it addresses is not guidance. It is a historical document. Earth is still speaking. Earth is still trying to help. But the help has been stripped of every quality that makes help useful. Immediacy, relevance, and the ability to change what happens next. And communication is only the first system to fail. Consider rescue. Inside the solar system, rescue is difficult, but not impossible. Apollo 13 demonstrated that a crew in mortal danger between Earth and the Moon could be guided home within days. Mars missions, when they eventually carry humans, will operate with the understanding that emergency return to Earth is measured in months. Long, dangerous, agonizing months, but a finite and survivable timeline. The crew could, in theory, turn around. They could abort. They could limp home on reduced systems and arrive to waiting medical teams and repair facilities and solid ground. Now, move the emergency to interstellar space. A ship traveling at 1% of the speed of light, which is roughly 6.7 million miles per hour and far beyond anything current propulsion can achieve, would take over 420 years to reach Proxima Centauri. A ship traveling at 10% of the speed of light, a figure that represents the optimistic upper bound of most serious propulsion concepts studied today, would take roughly 42 years. Even at that extraordinary velocity, a rescue mission launched from Earth the moment a distress call was received would take 42 years to arrive, plus 4.24 years for the distress call to reach Earth in the first place. That is a minimum response time of over 46 years, assuming instantaneous mission preparation, which is itself an absurd assumption. 46 years. Nearly half a century between the moment something goes wrong and the earliest possible arrival of help. No human being survives that timeline in an emergency scenario. No life support system is designed for it. No injury waits for it. No structural failure politely pauses while assistance is in transit. The rescue does not arrive late. It arrives in a different era. The people who needed saving are dead. The ship has either fixed itself or become a tomb. This is what happens at the nearest star. Scale the distance to 10 light-years, and the minimum rescue timeline stretches past a century. Scale it to 100 light-years, and you are talking about a millennium. The word rescue ceases to have meaning. It becomes a concept from a world that no longer applies, like a landlocked country discussing naval strategy. The vocabulary survives, but the reality it describes has evaporated. And with rescue goes the entire framework of contingency that every human mission in history has relied on. Every spacecraft ever built has been designed with the assumption that somewhere behind it there is a fallback, an abort mode, an emergency return trajectory. A team on the ground with spare parts and fresh ideas. A planet with hospitals and oxygen and gravity. Remove that fallback and the psychology of the mission changes fundamentally. The crew is not exploring with a safety net. They are existing without one. Every system on the ship is the only version of that system that will ever be available. Every resource on board is the total resource that will ever exist. Every crew member's expertise is the only expertise accessible for the duration of the mission and possibly the duration of their lives. This realization transforms the relationship between the traveler and Earth from an active partnership into a memory. Earth trained them. Earth built their ship. Earth packed their supplies and uploaded their databases and gave them everything it could before the departure. But once the distance grows large enough, Earth's contribution becomes entirely historical. It is what Earth did, not what Earth is doing. The present tense collapses. Earth exists in the past tense of the mission, a place where preparations were made, a place where the journey began, a place that recedes not just in space, but in relevance. Overtaken by the immediate reality of whatever is happening on the ship right now, in this moment, with no outside help available or forthcoming. navigation is the next system to detach from Earth. Inside the solar system, spacecraft navigate using a combination of methods that all ultimately reference Earth. The Deep Space Network tracks a probe's position by measuring the Doppler shift of its radio signal and the precise time delay of transmitted commands. Ground-based observations provide orbital calculations. Star trackers on the spacecraft itself identify known stars to determine orientation. But the coordinate system, the fundamental framework that defines where everything is relative to everything else, is anchored to Earth. The solar system's reference frame is centered on the Sun, but the practical work of navigation is performed by people and computers on Earth using Earth-based instruments. In interstellar space, this system disintegrates. The Deep Space Network cannot track a spacecraft at interstellar distances because the signal is too faint. Even if communication were possible, the light travel delay makes real-time navigation updates impossible. A spacecraft traveling at 10% of light speed covers roughly 67 million miles per hour. By the time a navigation correction transmitted from Earth reaches the ship has moved billions of miles from where it was when the correction was calculated. The update is not slightly stale. It is obsolete to a degree that makes it dangerous to apply. An interstellar spacecraft must navigate autonomously. It must carry its own star catalogs, its own computational systems, its own ability to determine where it is in three-dimensional space relative to its destination without any input from Earth. The familiar constellations will have shifted. Stars that appear in fixed positions from Earth's perspective will show measurable parallax from a vantage point light-years away. Orion will not look like Orion. The Big Dipper will not look like the Big Dipper. The sky itself will be foreign, rearranged by the simple fact of being somewhere else. Navigation becomes a local problem, solved with local resources. Earth's maps are a starting point, not a live feed. The psychological weight of this navigational independence deserves more attention than it typically receives in discussions of interstellar travel. Consider what it means to look out of a window and not recognize the sky. Every human culture in history has organized its relationship with the cosmos around the patterns visible from Earth's surface. The constellations are not physical groupings. They are projections, shapes imposed by the human eye on stars that are actually separated by vast distances in three-dimensional space. Orion's belt is not a belt. It is three stars at wildly different distances from Earth that happen to line up from our particular vantage point. The Big Dipper is not a ladle. It is 7 stars scattered across a volume of space hundreds of light-years deep that happen to form a recognizable shape when viewed from one specific location in the galaxy. Move that location by even a few light-years and the shapes change. Stars that appeared close together from Earth are revealed to be at different depths, their apparent proximity an accident of perspective. New alignments emerge. Old ones dissolve. The sky that every human being who has ever lived looked up at and used to mark seasons, navigate oceans, tell stories, and orient their sense of place in the cosmos rearranges itself into a configuration that no human eye has ever seen. This is not a subtle effect. At a distance of 10 light-years from the Sun, many of the most recognizable constellations would be noticeably distorted. Stars in the foreground of familiar patterns would have shifted measurably relative to stars in the background. Some constellations would still be vaguely recognizable, others would be unrecognizable entirely. And new patterns would have formed, shapes that have no names, that correspond to no mythology, that carry no emotional weight from any human tradition. The traveler looking out the window would see a sky that is objectively beautiful. Stars by the thousands, sharp and steady in the absence of atmosphere, spanning the full sphere of the visible universe. but it would be a sky without meaning, without names, without the layered association of centuries of human storytelling and wayfinding. The stars would be data points, not landmarks, useful for navigation only through computational reference to onboard catalogues, not through the intuitive recognition that every sailor and shepherd in human history relied on. This might sound like a minor inconvenience compared to the loss of communication or rescue. It is not. The human relationship with the sky is one of the oldest and most deeply embedded features of the species' cognitive architecture. Long before written language, before agriculture, before permanent settlement, humans looked at the stars and built frameworks of meaning around them. Those frameworks were navigation. They were religion. They were calendar. They were story. Losing them is not like losing a map. It is like losing a language. The sky still speaks, but it speaks in a tongue the traveler was never taught, and the translation guide is a database, not a heritage. For the traveler, the unfamiliar sky is a constant, inescapable, visual reminder of displacement. You cannot close the window. You cannot project Earth's constellations onto the glass and pretend the shapes are still there. Every time you look outside, the universe tells you that you are somewhere else, somewhere that does not know your stories, somewhere that was never shaped by your presence or your species' history, somewhere that existed for billions of years before your civilization arose and will exist for billions of years after every trace of it has vanished. The sky does not reject you. It simply does not include you. And that quiet exclusion, repeated every time the traveler raises their eyes, is a form of alienation that no amount of preparation can fully inoculate against. And then there is the question of the sun itself. Inside the solar system, the sun dominates everything. It is the source of light, warmth, energy, and gravitational order. It is the brightest object in the sky from any point within the heliosphere. It is the reference point around which every planet, asteroid, and comet defines its orbit. It is, in every practical sense, the center of the world, not Earth, the sun. Earth is the center of human meaning. The sun is the center of physical reality for the entire system. As you move away from the sun into interstellar space, it fades, not dramatically at first. From the distance of the Oort cloud, roughly 1 light-year, the sun would still be a bright star, easily visible, comparable in brightness to some of the brightest stars visible from Earth. But it would no longer look like the sun. It would not dominate the sky. It would not illuminate the ship. It would be a point of light among thousands of other points of light, identifiable only if you knew where to look. From 2 light-years, it would be dimmer. From 5 light-years, dimmer still. From 10 light-years, the sun would be a faint star visible to the naked eye, but unremarkable, a yellowish dot lost in a sky crowded with brighter neighbors. You would need a chart to find it. And Earth, orbiting that faint dot at a distance of 1 astronomical unit, would be completely invisible. No telescope you could carry on a spacecraft would resolve it. The planet where 8 billion people live, where every city glows at night, where satellites swarm in orbit, where the entire history of human civilization unfolded, would not register as a single pixel of light in the darkness. This is not a metaphor for insignificance. It is an optical fact. Earth does not emit enough light to be visible at interstellar distances. It reflects a tiny fraction of the sun's output. From 10 light-years away, the reflected light of Earth would be roughly 10 billion times fainter than the sun itself, which is already a faint star at that distance. Earth would be buried in the glare of its own star, invisible even to instruments specifically designed to find it. The traveler would know, intellectually, that Earth is there. They would know its coordinates. They could point to the correct spot in the sky and say, "That is where I come from." But they would see nothing. No blue dot, no pale light. No visible reminder that the place exists. The visual connection, the most primal and immediate link between a person and their sense of place, would be severed entirely. Home would not look like anything. It would be a location in a database, a set of numbers in a navigation system, an idea maintained by memory and nothing else. Consider how this cascading loss accumulates. First, communication becomes impossible or meaninglessly delayed. Then, rescue becomes physically unachievable within any relevant time frame. Then, navigation detaches from Earth-based references and becomes a self-contained onboard function. Then, the sun fades from a life-giving star to a faint point in a crowded sky. Then, Earth itself vanishes from sight entirely. Each of these losses is independent. Each follows from the same cause: distance. And distance in interstellar space does not grow in the gentle, linear way that human intuition expects. The jump from the outer solar system to the nearest star is not like the jump from Earth to Mars or from Mars to Jupiter. It is a change in category. It is like comparing the width of a river to the width of an ocean. The numbers are not just bigger. They are bigger in a way that transforms the nature of every problem associated with them. A river can be bridged. An ocean requires a fundamentally different kind of vessel, a fundamentally different kind of preparation, and a fundamentally different relationship with the shore you left behind. Inside the solar system, the shore is always visible. The tether to Earth stretches but holds. The connection weakens but persists. Home is far away but reachable, at least in principle, at least with enough time and fuel and determination. The boundary of the heliosphere is the farthest point at which this remains true. Beyond it, the tether does not just stretch further, it changes substance. It becomes something that can carry information only across timescales, longer than human decisions, longer than human emergencies, longer than human patience, and in many cases, longer than human lives. Earth has not abandoned the traveler. Earth has not chosen to withdraw its support. Earth is still there, still spinning, still populated by people who might care deeply about the mission and the crew. The deep space network might still be pointing its dishes at the correct patch of sky, listening for a signal that will never arrive at detectable strength. Mission planners might still be updating contingency plans that can never be transmitted in time. Families might still be waiting for messages that will take years or decades to arrive. None of that changes what has happened. The distance has made Earth's care, Earth's expertise, Earth's infrastructure, and Earth's love operationally irrelevant, not emotionally irrelevant. The traveler may think about Earth every single day. They may dream about rain and wind and the sound of birds at dawn. They may carry photographs, play recordings, write letters they know will not arrive for years. Earth may remain the most important place in their psychological universe, but the psychological universe and the physical universe have diverged. In the physical universe, Earth is a point of origin that cannot hear you, cannot reach you, cannot help you, and cannot see you. Everything it once provided, protection, communication, rescue, navigational authority, visual presence, has been stripped away by nothing more dramatic than distance. No villain intervened. No catastrophe occurred. The ship did not malfunction. Earth did not fall silent. The geometry of the universe simply asserted itself across a gap so vast that every human system designed to bridge distance failed, not because the systems were poorly built, but because they were built for a world where the nearest shore was never more than an ocean away. The traveler is now standing on the other side of something much wider than an ocean, and the shore they left behind has dropped below the horizon, not because it sank, because the curvature of reality itself has hidden it from view. What remains is the ship, the walls, the air, the crew, the systems, the stored knowledge. everything that exists within arm's reach. That is the new world. That is the new center. Not because the traveler chose it, but because the universe left no alternative, and the transformation is not yet complete. Because losing communication, losing rescue, losing sight of home, these are the mechanical failures, the structural collapses. The things that can be measured in watts and light years and hours of signal delay. What comes next is quieter, stranger, and in many ways more devastating. It is the moment when the traveler realizes that Earth is not just unreachable. Earth has become irrelevant to the conditions of their survival. The air they breathe is not Earth's air. The food they eat was not grown in Earth's soil. The decisions that determine whether they live or die are made by people Earth has never met, in circumstances Earth cannot observe, under pressures Earth cannot feel. Earth's authority, Earth's culture, Earth's institutions, Earth's entire framework for organizing human life has become a set of inherited habits operating in a place where they were never tested and where their creators have no power to enforce or update them. The traveler has not left. Home has left them, not willingly, not cruelly, just completely. There is a moment in every long ocean voyage, from the age of sail that sailors wrote about, with striking consistency across centuries and cultures. It is the moment when the last sliver of coastline drops below the horizon. The ship has not changed. The wind has not shifted. The crew is the same. The mission is the same. But something inside, every person on board recalibrates. The land is gone. The world they knew is no longer visible. From this point forward, the ship is the world. The deck is the ground. The hull is the horizon. Everything that matters exists within the wooden walls surrounding them, and everything beyond those walls is either ocean or sky, neither of which cares whether they survive. Sailors describe this moment with words like dread, freedom, loneliness, and resolve, sometimes all in the same sentence. It was not the most dangerous moment of the voyage. Storms and scurvy and mutiny would come later. But it was the moment when the psychological contract changed. The shore was no longer a thing you could see. It was a thing you had to believe in. A thing you carried in memory and navigated toward on faith, using instruments and stars and the accumulated knowledge of everyone who had made the crossing before you. Now remove the possibility of return. Remove the stars the sailor recognizes. Remove the certainty that the shore still exists in any form the sailor would recognize when they arrive. Remove the ocean itself and replace it with a vacuum so vast that the crossing takes not months, but generations. What remains is not a voyage, it is a permanent departure. And the psychological architecture of every human being who attempts it will be tested against conditions that no member of the species has ever faced. Inside the solar system, astronauts experience isolation, but it is isolation with a flaw. The International Space Station crew lives in a confined space for months at a time, separated from family, from weather, from the feeling of wind on skin. They undergo rigorous psychological screening before flight and receive ongoing mental health support from specialists on the ground during their missions. Communication with Earth is nearly instantaneous. Video calls with family happen regularly. News arrives in real time. If an astronaut experiences a psychological crisis, a trained counselor can be speaking with them within minutes. Mars missions, when they carry humans, will push this system further. Communication delays of up to 24 minutes each way will make real-time counseling impossible. Crews will need to manage their own interpersonal conflicts, their own emotional crises, their own psychological deterioration without immediate Earth-based intervention. Researchers at NASA and the European Space Agency have spent decades studying the effects of long-duration isolation on small groups. The results are consistent and sobering. Conflict increases over time. Sleep quality degrades. Motivation fluctuates. Group dynamics shift in unpredictable ways, with alliances forming and dissolving under the pressure of confinement. Depression, irritability, and cognitive decline have all been documented in analog studies simulating Mars-duration missions on Earth. But even the most pessimistic Mars isolation study operates under one fundamental assumption, that interstellar travel destroys. The crew is coming home. The mission has an end date. The suffering is temporary. The confinement will lift. The door will open. Earth is waiting on the other side, and the return journey, however long and difficult, is part of the plan. An interstellar mission has no return journey, not in any practical sense. A ship traveling at 10% of the speed of light would take over 42 years to reach Proxima Centauri. The crew that departed Earth would arrive in their 60s or 70s, assuming they survived. The return trip would take another 42 years. A round trip at 10% of light speed to the nearest star and back would consume roughly 84 years. No crew that left Earth as adults would live to see home again. The mission is one way, not by tragic accident, but by the inescapable arithmetic of distance and speed. This changes everything about the psychology of the journey. Every study of human isolation, every analog mission, every psychological model developed for spaceflight assumes a return. Remove the return, and the entire framework collapses. The crew is not enduring temporary hardship for a future reward. They are living the rest of their lives inside a vessel that is simultaneously their home, their workplace, their hospital, their government, and their entire civilization. There is no after. There is no when we get back. There is only the ship, the mission, and the slow passage of years in a metal container crossing the void between stars. The psychological literature has a term for the experience of looking back at Earth from space and feeling a profound shift in perspective. It is called the overview effect. Astronauts who have seen the whole planet from orbit describe a sudden, overwhelming sense of the fragility and unity of life on Earth. The borders disappear. The conflicts seem petty. The planet looks alive, beautiful, and heartbreakingly small against the black of space. The overview effect depends on one critical condition: you can see Earth. You can look down and watch the continents drift past. You can see the thin blue line of the atmosphere. You can identify the landmass where your family lives. The emotional power of the experience comes from the combination of distance and visibility. You are far enough to see the whole, but close enough to recognize the parts. Interstellar distance eliminates this entirely. There is no overview effect when there is nothing to overview. The traveler cannot see Earth, cannot see the sun, cannot see the solar system. The place they came from is a coordinate in a star catalogue, a set of numbers that corresponds to a dot too faint to detect with any instrument on board. The overview has become a blank. The window shows nothing but unfamiliar stars, and the emotional response to that blankness is not the humbling awe of the overview effect. It is something closer to vertigo. The sensation of looking for a handhold and finding empty air. Researchers studying extreme isolation on Earth have documented a phenomenon they call third quarter syndrome. It occurs in Antarctic winter-over cruise, submarine deployments, and long-duration spaceflight simulations. Roughly 3/4 of the way through a mission, morale drops sharply. Motivation collapses, irritability spikes. The pattern is remarkably consistent across different cultures, different mission types, and different crew compositions. The cause appears to be psychological. The novelty of the mission has worn off. The end is visible but still distant. The crew enters a trough of low energy and high frustration, that typically lifts only as the return approaches. On an interstellar mission, there is no third quarter. There is no return approaching to lift the trough. The mission duration is not measured in months or years, but in decades or lifetimes. Third quarter syndrome, or something far worse, could become the permanent baseline psychological state of the crew. And no counselor on Earth can help, because by the time their advice arrives, the crisis that prompted the call happened years ago. Now consider the institutional structures that humans depend on: law, governance, medical authority, chain of command. Every crewed space mission in history has operated under a clear, legal, and organizational framework. Astronauts on the International Space Station are subject to intergovernmental agreements that define jurisdiction, responsibility, and authority. If a crime were committed on the station, there are legal protocols for determining which nation's laws apply. If a medical decision must be made, flight surgeons on the ground have the authority to override crew preferences based on mission safety. The commander has defined powers. The chain of command traces back through the space agency to the government that funded the mission. All of this depends on communication. Law is not a physical force. It is a set of agreements enforced by institutions that can observe, judge, and act. When the distance between the governed and the governing becomes so large that observation takes years, judgment takes decades, and action is physically impossible, the law does not technically vanish. It becomes unenforceable, and an unenforceable law is not a law. It is a suggestion. An interstellar crew would carry Earth's laws with them the way sailors carried their king's charter. As a document, a tradition, a set of principles inherited from the place of origin. But the power behind those principles, the courts, the enforcement agencies, the prisons, the appeals processes, all of it exists on a planet that cannot observe what is happening on the ship, cannot intervene in disputes, and cannot impose consequences on anyone who violates the rules. The crew would need to govern themselves. They would need to develop their own mechanisms for resolving conflicts, distributing resources, making collective decisions, and enforcing standards of behavior. They would need their own medical authority, empowered to make life and death decisions without consulting physicians on Earth. They would need their own judicial process, capable of handling everything from minor disputes to serious violations without any external oversight. They would need, in short, to become their own civilization. This is not a theoretical concern. It is a structural inevitability. A group of human beings isolated beyond the reach of any external authority for decades or longer will develop their own social systems. History demonstrates this repeatedly. Isolated communities, whether on remote islands, in frontier settlements, or in enclosed religious orders, always develop local norms, local hierarchies, and local rules that diverge over time from the systems of the parent culture. The longer the isolation, the greater the divergence. After a generation, the differences are noticeable. After several generations, the community may be culturally unrecognizable to its origin society. An interstellar ship carrying multiple generations of crew would undergo the same process. The grandchildren of the original crew would grow up knowing Earth only as a story. A place described in databases and recordings, referenced in historical documents, invoked in speeches and rituals, but never seen, never visited, never experienced. Their relationship to Earth would be similar to a modern person's relationship to the ancestral homeland their great-great-grandparents emigrated from. Acknowledged, perhaps revered, but fundamentally abstract. The ship would be their home. The ship's culture would be their culture. Earth's traditions would be their mythology. To understand how complete this cultural transformation would become, consider what 3 generations of shipborne life actually looks like. The first generation, the original crew, carries Earth in living memory. They remember weather. They remember the sound of wind through trees, the smell of rain on dry ground, the sensation of swimming in open water. They can describe these experiences to their children with the authority of first-hand witness, and their descriptions carry emotional weight because the teller's voice changes when they speak about things they genuinely loved and lost. The second generation, born on the ship, knows Earth only through the testimony of their parents and the archives they can access. They have never felt rain. They have never seen an unenclosed horizon. They have never experienced gravity that was not generated by the spin of their vessel. Their parents' stories about Earth are vivid and emotionally compelling, but they land on a mind that has no sensory framework to receive them. When a first-generation crew member describes the feeling of standing on a beach watching waves, the second-generation listener can construct an intellectual model of the experience, but they cannot feel it. The words arrive without the physical memory to anchor them. Beach, wave, sand, wind. These are vocabulary items, not experiences. They are learned the way a child learns about dinosaurs, as real things that existed in a world the child has never visited. By the third generation, Earth has receded another full step into abstraction. The grandparents who remembered Earth firsthand are elderly or dead. The parents who received the stories secondhand are now the senior voices on the ship, and their version of Earth is already a reconstruction, shaped by their own imagination, filling in the sensory gaps their parents' words could not fully convey. The third generation receives a story about a story. Earth is now twice removed from direct experience, filtered through 2 layers of imperfect transmission, and the version they carry in their minds is a composite of database images, archived recordings, parental narratives, and their own unconscious embellishment. This third generation does not feel displaced from Earth. They do not mourn it the way the first generation mourned it. They were never there. Their home is the ship. Their sky is the corridor ceiling. Their weather is the climate control system. Their horizon is the far wall of the largest compartment. They know Earth is important because everyone says so, but the importance is inherited, not felt. It is the importance of a founding myth, powerful and identity-shaping, but not personally experienced. They honor Earth the way a nation honors its founders, with reverence and ritual and a quiet awareness that the real people behind the legends were probably more complicated and less heroic than the stories suggest. The ship's culture by this point has developed its own holidays, its own humor, its own art forms, adapted to the constraints of enclosed space. Music has evolved to suit the acoustics of metal corridors. Visual art favors the materials available on board. Language has shifted, not dramatically, but enough that a recording of the original crew's speech sounds slightly formal and old-fashioned to third-generation ears. They have their own slang, their own references, their own shared memories that have nothing to do with Earth and everything to do with events that happened on the ship during their lifetimes. The reactor malfunction of year 37, the birth of the first child in the second habitation ring, the time the navigation system misidentified a dust cloud as a rogue planet, and the entire crew spent 3 days preparing for an encounter that turned out to be nothing. These are the stories that matter to the third generation. Not because Earth's stories are unimportant, but because the ship's stories are theirs. They lived them, they felt them. They carry the sensory memory of those events in their bodies, the way the first generation carried the sensory memory of rain and wind and open sky. Earth is their heritage, the ship is their home. And the distance between heritage and home grows wider with every generation that lives and dies without ever touching the soil of the planet their great-grandparents wept to leave behind. And Earth, receiving transmissions from the ship years or decades after they were sent, would watch this divergence happen in slow motion, unable to intervene, unable to correct, unable to impose its values or update its instructions. Earth would become the elderly grandparent speaking into a phone, offering advice about a world they no longer understand to people who are too polite to say it does not apply anymore. Now, add relativity. Special relativity, one of the most rigorously tested frameworks in all of physics, dictates that time passes differently for objects moving at different velocities. The effect is negligible at everyday speeds. It becomes measurable at significant fractions of the speed of light. A ship traveling at 10% of the speed of light would experience time dilation of roughly 0.5%, barely noticeable. But at 50% of light speed, the dilation becomes significant. Time on the ship would pass roughly 15% slower than time on Earth. At 90% of light speed, time on the ship would pass at less than half the rate of Earth time. This means that the faster the ship travels, the more the clocks diverge. A crew traveling at high relativistic speeds would age more slowly than the people they left behind. They might experience 10 years of subjective time, while Earth experiences 20. They might arrive at a distant star feeling as though a decade has passed, only to learn from delayed transmissions that Earth has aged a generation in the interim. The practical effect of this is disorienting in a way that no previous human experience has prepared anyone for. The crew would receive messages from Earth that reference events, cultural shifts, political changes, and technological developments that have occurred in a time frame longer than their subjective experience. Earth would feel as though it is accelerating away from them in time, changing faster than their own experience of duration can account for. The home they remember would be replaced by a home they do not recognize, and the replacement would happen while they were watching, in transmissions that arrive increasingly out of sync with their own lived reality. Imagine receiving a message from your family that references 10 years of events you did not experience, birthdays you missed, deaths you did not mourn in real time, children born and grown that you have never met, political upheavals that reshaped the society you thought you belonged to. The message is warm, loving, full of news. But the news describes a world that has moved on without you, at a pace your body and mind did not share. You are not estranged from Earth. You are temporarily displaced from it. You belong to a version of home that no longer exists. This is not a one-time shock. It is a continuous condition. Every message from Earth would deepen the temporal disconnect. Every year of ship time that passes would correspond to a longer stretch of Earth time. The crew would slowly become anachronisms, people from a past that Earth has outgrown, carrying values and assumptions calibrated to a version of civilization that has evolved beyond them. And Earth would face the inverse problem. The messages arriving from the ship would reference conditions, decisions, and crises from the ship's past that Earth cannot influence. By the time Earth receives a message describing a problem on the ship has already solved it, failed to solve it, or ceased to exist. Earth's response, transmitted years later, arrives as a commentary on ancient history. The conversation is not delayed, it is fractured. Two timelines running at different speeds, exchanging information that is always outdated by the time it arrives. Each party living in a present the other cannot access. To make this concrete, imagine a crew member who departed Earth at age 30, leaving behind a younger sister who was 25 and recently married. The ship accelerates to a significant fraction of light speed. 5 years of subjective ship time pass. The crew member is now 35. They receive a transmission from Earth, delayed by years of travel time and further complicated by relativistic time dilation. In the message, the sister is not 30, she is 41. She has 3 children, the oldest of whom is 12. She mentions in passing that their mother died 4 years ago, Earth time. The crew member never received a message about the death because the transmission was sent during a period when the ship's receiver was undergoing repair. The crew member is now mourning a parent who has been dead by Earth's clock for 4 years. By the ship's clock, the death occurred during what felt like an ordinary Tuesday 18 months ago. The grief is real. The loss is real. But the timing is dislocated. There was no phone call in the night, no gathering of family, no funeral to attend. The event happened in a different time stream, and the news arrived the way archaeological discoveries arrive, as a fact about the past delivered without ceremony into an unrelated present. Now extend this across decades. The crew member at ship age 45 receives a message from a niece they have never met, now a grown woman with children of her own, writing in a dialect of English that has shifted enough to require careful reading. The niece references political structures, cultural norms, and technologies that the crew member has never encountered. She mentions a war that began and ended entirely within the gap between transmissions. She uses idioms the crew member does not recognize. She closes the message with warmth and affection for an uncle she has never seen in person and knows only through family stories and old recordings. The crew member reads the message and understands every word individually. But the world the message describes is not the world they left. The institutions they trained under have been restructured or dissolved. The space agency that launched their mission has merged with 3 other organizations and operates under a different name with different priorities. The city where they grew up has changed its skyline, its demographics, and several of its street names. The language they speak is still technically current on Earth, but the version they speak marks them as historical, the way reading a letter from the 1940s feels slightly foreign to a person living today. Not incomprehensible, just unmistakably from another time. This is the temporal version of the visual displacement described by the unfamiliar sky. The traveler's Earth still exists, but it has become a different place, changed by time in ways the traveler did not experience and cannot fully absorb. They belong to a version of Earth that no longer exists on Earth itself. They are cultural fossils, carrying the habits, references, and assumptions of a departed era into a present that has moved on without them. Now consider the Sun. From inside the solar system, the Sun is the unmistakable center of physical reality. It provides light and heat to every planet. Its gravity holds the system together. Its radiation defines the boundary of the heliosphere. Its position in the sky is the reference point for every calendar, every clock, every agricultural cycle, every religious observance tied to solstice and equinox and the passage of seasons. The Sun is not just a star, it is the organizing principle of the only world humans have ever known. From 10 light-years away, the Sun is a faint star. Approximately apparent magnitude 4.7, visible to the naked eye but far from prominent. It would appear roughly as bright as a moderately dim star in the constellations visible from Earth. It would not illuminate the ship. It would not warm anything. It would carry no practical significance for the crew's survival. Their energy would come from onboard reactors or whatever propulsion system drives the vessel. Their light would come from artificial sources. Their warmth would come from insulated systems designed to preserve heat in the vacuum of space. The Sun's contribution to their daily existence would be zero, and Earth, orbiting that faint dot, would be so far below the threshold of detection that it might as well not exist as a physical object. The crew could calculate its position. They could point a telescope at the exact coordinates and see nothing but the dim glow of a star indistinguishable from thousands of others. Earth would be there, theoretically, provably, mathematically, but not visibly, not tangibly, not in any way that a human nervous system evolved on the African savanna could register as real. This is where the operational disappearance becomes total. Communication is either impossible or meaninglessly delayed. Rescue is a fantasy that requires lifetimes to execute. Navigation no longer references Earth. Governance has become self-contained. Time itself has diverged. The sun is a faint star among many. Earth is invisible. Every system, every structure, every assumption that connected the traveler to their point of origin has been stripped away, not by malice or failure, but by the simple, implacable, utterly indifferent fact of distance. The ship is now a self-contained civilization, not metaphorically, operationally. The air inside it is the only breathable air within light years. The walls are the only barrier between the crew and a vacuum that would kill them in seconds. The food supply is the only food supply. The medical bay is the only hospital. The crew is the only society. Everything that sustains human life, every resource, every relationship, every institution exists within the hull of the vessel. Nothing outside the ship contributes to survival. Nothing outside the ship can be reached in time to matter. Earth has become what a childhood home becomes to a person who emigrated to another continent decades ago and lost all means of contact. A place that shaped them. A place they carry in their identity. A place that exists in the stories they tell and the habits they maintain. But not a place that can feed them tonight, or fix the leak in the roof, or answer the phone when they call. The emotional bond survives. The operational bond is gone. And the most disorienting part of this transformation is how gradually it occurs. There is no single moment when Earth stops being relevant. No alarm sounds. No boundary marker announces that you have left the range of home's protection. The signal fades by degrees. The communication delay grows minute by minute. The sun dims so slowly that no single observation reveals the change. One day you realize that the last message from Earth arrived 3 years ago, and you forgot to notice when it stopped feeling urgent. One day you realize that the navigational display no longer shows Earth's position unless you manually query it. One day you realize that the crew has stopped referencing Earth time in their daily schedules, using instead a local timekeeping system calibrated to the ship's rotation and the crew's sleep cycles. Each of these moments is small, forgettable, unremarkable in isolation. Together, they constitute the most profound transition any human being has ever undergone. The transformation from a person who belongs to a world to a person who belongs only to the vessel carrying them through the dark, the traveler has not been exiled. They chose this journey, or their ancestors chose it for them. Earth did not push them away. Earth launched them with everything it had, with the best technology available, with the accumulated knowledge of the entire species, with love and hope and the best intentions a civilization could muster. Earth gave them everything it could give. And then distance took everything else. What remains, the only thing that survives the crossing from Earth's domain into interstellar space intact and undiminished, is the one thing that distance cannot degrade. Memory. The idea of home. The knowledge that somewhere behind them, impossibly far, impossibly dim, a blue planet orbits a yellow star, and on that planet, life goes on. People wake up, children are born, rain falls on oceans, seasons turn. That knowledge is real, it is precious. It may be the most important thing the traveler carries, but it cannot pressurize the hull. It cannot synthesize medicine. It cannot repair a fractured reactor. It cannot answer a question faster than the speed of light allows. It cannot cross the distance between stars to deliver a single molecule of breathable oxygen to a crew that is suffocating. Memory is what Earth becomes at interstellar distance, not a power, not a resource, not an authority, a memory, warm, vivid, achingly beautiful, and completely powerless to change what happens next. The traveler knows this. Perhaps they knew it before they left. Perhaps they understood the arithmetic, the physics, the brutal logic of the inverse square law and the light speed barrier and the meaning of a number like 4.2, 4 light-years. Perhaps they stood on the launch pad, looked up at the sky, and understood in the abstract that they were about to sever every practical connection to the only world their species had ever called home. But understanding it in the abstract and living it in the dark are two different things. The abstract is a number on a page. The reality is a window full of unfamiliar stars and a silence where Earth's voice used to be. And between those two experiences, between the number and the silence, lies the full weight of what it means to leave the solar system and discover that home cannot follow you. What comes next is not the mechanics of that loss. It is the meaning of it, the question that sits at the center of the silence, waiting for anyone brave enough or far enough away to finally hear it clearly. There is a photograph taken on February 14th, 1990, that has become one of the most reproduced images in the history of the human species. It was not planned as a scientific observation. It had no research value. It would reveal no new data about any planet, moon, or asteroid. The camera that took it was about to be shut down permanently, its mission complete, its power budget dwindling. But before the final commands were sent, astronomer Carl Sagan convinced NASA to turn Voyager 1's camera around and take one last picture of home. The image shows a field of scattered light. Rays from the sun caught in the camera's optics, creating pale streaks across the frame, and there, suspended in one of those streaks, almost invisible, is a tiny dot, less than a single pixel in size, bluish, faint, easily mistaken for a speck of dust on the lens or a processing artifact in the data. That dot is Earth. Every person who has ever lived, every war that has ever been fought, every song that has ever been sung, every birth and death and heartbreak and discovery in the entire history of a species that has spent its whole existence on that single grain of light. Sagan wrote about the photograph in words that have been quoted so often they have become almost invisible through familiarity. But the core of what he said was not poetry. It was a precise observation about scale. The Earth is a very small stage in a vast cosmic arena, he wrote. And he was right. But the photograph was taken from a distance of roughly 3.7 billion miles, 40 astronomical units, still inside the solar system, still within the heliosphere, still close enough for Voyager's signal to reach the deep space network. Still close enough that the sun was the dominant light source in the sky, and Earth, however faint, was detectable. The pale blue dot is often presented as the ultimate statement about human insignificance. But it is not. It is the last photograph in which Earth is visible at all. Beyond that distance, the dot does not get smaller. It disappears. The camera could be pointed at the exact right coordinates with perfect precision, and it would capture nothing. Not a dimmer dot, not a fainter glow, nothing. The light, reflected from Earth's surface, is so weak that it falls below the detection threshold of any instrument that could reasonably be carried on a spacecraft. The pale blue dot is not a portrait of insignificance. It is a farewell portrait, the last image taken before the subject vanishes permanently from sight. That distinction matters for everything that follows. Because the journey this story has been tracing, The journey from Earth's surface into interstellar space is not a journey into insignificance. It is a journey into disconnection. And disconnection is not the same thing as meaninglessness, even though from the inside they can feel identical. Consider what the traveler carries when they cross into interstellar space. They carry the knowledge that Earth exists. They carry language, culture, memory, identity. They carry the biological inheritance of 4 billion years of evolution on a specific planet with specific conditions. Their bones are calibrated to Earth's gravity. Their circadian rhythm is tuned to a 24-hour day. Their immune system was trained by Earth's microorganisms. Their emotional responses were shaped by millions of years of social living in small groups on a planetary surface where the sky changed with the seasons and the horizon always promised more land beyond it. Every cell in their body is a record of Earth. Every reflex, every instinct, every unconscious expectation about how reality should behave was written by the planet they left behind. They are, in the most literal biological sense, made of Earth, constructed from its materials, shaped by its forces, encoded with its history. Earth is not something they left. Earth is something they are. And yet, none of that changes the physics. The traveler is made of Earth, but Earth cannot reach them. Their body remembers home, but home cannot hear their body. The connection is written into their DNA and simultaneously erased by the distance between stars. They carry Earth in every atom, and Earth cannot deliver a single photon of useful light to their position. The intimacy of the bond and the totality of the separation exists simultaneously, without contradiction, without resolution. This is the paradox at the heart of the title. Earth does not stop meaning something to the traveler, it stops being able to do something for the traveler. And in the specific context of survival, of operational reality, of the immediate physical question of whether you live or die in the next hour, meaning without capability is not enough. You cannot breathe meaning. You cannot repair a hull breach with emotional attachment. You cannot navigate by nostalgia. The traveler loves Earth. Earth loves the traveler. And love, across 4 light-years of vacuum, cannot close a wound or pressurize a compartment or answer a distress call before the oxygen runs out. This is not nihilism. Nihilism would say Earth does not matter. The truth is precisely the opposite. Earth matters enormously. Earth is the origin of everything the traveler is, everything they value, everything they hope to preserve. Earth matters so much that losing practical access to it constitutes one of the most profound losses a human being could ever experience. If Earth did not matter, the distance would not hurt. The distance hurts precisely because Earth matters, and because mattering is not enough to overcome the speed of light. There is a concept in psychology called ambiguous loss. It was developed by researcher Pauline Boss in the 1970s to describe situations where a loved one is absent but not confirmed gone. A soldier missing in action. A family member with advanced dementia who is physically present but psychologically unreachable. The grief associated with ambiguous loss is particularly devastating because it offers no closure. The person is not dead. They are not alive in any accessible sense. They exist in a suspended state that the mourner cannot resolve. Interstellar distance creates a form of ambiguous loss on a civilizational scale. Earth is not gone. It has not been destroyed. 8 billion people are still living their lives, still building, still dreaming, still looking up at the same stars. But from the traveler's perspective, Earth is unreachable, not temporarily, not until the next launch window or the next orbital alignment, permanently. For the rest of their life, and possibly for the rest of their descendants' lives, Earth exists. Earth is alive. And Earth cannot be accessed, contacted, or returned to within any time frame that the traveler will experience. The mourning that accompanies this realization is unlike any grief humans have previously encountered. It is not the grief of death, because nothing has died. It is not the grief of separation, because separation implies the possibility of reunion. It is the grief of permanence. The slow, crushing understanding that the distance is not a problem to be solved, but a condition to be endured. That no amount of ingenuity, determination, or longing will bring Earth 1 light-year closer. That the laws of physics, which gave the traveler everything they needed to survive on Earth's surface, are the same laws that now make Earth's surface forever beyond their reach. And here is where the deeper meaning of the title reveals itself. When we say Earth means nothing once you leave the solar system, we are not making a statement about Earth's value, we are making a statement about Earth's power. Inside the solar system, Earth has power. The power to communicate, to intervene, to rescue, to govern, to provide. Earth's meaning and Earth's power are fused together. They feel like the same thing because they have always operated together. You have never experienced Earth's meaning without Earth's power backing it up. The love of home has always come packaged with the protection of home. The emotional bond has always been reinforced by the practical bond. They are so intertwined that most people cannot imagine one without the other. Interstellar distance separates them. For the first time in the history of the species, a human being would experience Earth's meaning without Earth's power. They would feel the full emotional weight of belonging to a world that has no operational relevance to their survival. They would carry the identity of a civilization that has no authority over their circumstances. They would love a home that cannot help them and long for a place that cannot hear them. And the combination of intense attachment and complete helplessness would constitute a psychological experience for which no precedent exists and no preparation is possible. Consider the Voyager Golden Record. Launched in 1977, both Voyager spacecraft carry a gold-plated copper disc containing sounds and images selected to portray the diversity of life and culture on Earth. There are greetings in 55 languages. There are samples of music from around the world, from Bach to Chuck Berry to Javanese gamelan. There are images of humans, animals, landscapes, and mathematical diagrams. There are recordings of thunder, birdsong, heartbeat, and laughter. The record is a message in a bottle, thrown into the cosmic ocean with the hope that someday someone might find it and know that we existed. The Golden Record is often celebrated as an act of optimism, and it is. But viewed through the lens of interstellar distance, it is also one of the most poignant gestures of helplessness ever created. The record travels at roughly 38,000 miles per hour. At that speed, it will drift for tens of thousands of years before passing within range of the nearest star. And it is not heading toward the nearest star. It is heading into open space, drifting through a galaxy containing hundreds of billions of stars, each separated by light-years of vacuum. The probability that any other intelligence will ever encounter it is so close to zero that the distinction is academic. The Golden Record is not a practical communication. It is a prayer, a whisper thrown into an abyss so vast that the whisper will travel for millions of years without encountering a single ear. It is the gesture of a species that understands, on some level, that the distances between stars are not bridges waiting to be crossed, but voids that swallow everything thrown into them, including sound, including light, including hope. And yet, the gesture was made. The record was built, loaded with the best of what humanity could offer, and launched into the dark. Not because anyone expected it to work, but because the alternative, saying nothing, sending nothing, letting the silence speak for itself, was unbearable. The Golden Record is Earth's love letter to a universe that may never read it, and love letters sent to addresses that may not exist, carried by messengers that may never arrive, are not meaningless. They are the most meaningful thing a species facing its own cosmic solitude could possibly create. This is the tension the traveler lives with. Earth's meaning does not diminish with distance. In some ways, it intensifies. The farther you are from home, the more precious home becomes. The more unreachable it grows, the more fiercely you hold on to the idea of it. Astronauts in low Earth orbit report intensified emotional connections to home. Researchers at Antarctic stations describe heightened nostalgia during the long polar winter. Submariners on extended deployments dream about sunlight and open air with an almost hallucinatory vividness. At interstellar distance, this intensification would have no ceiling and no release. The traveler would carry an idealized Earth in their mind, a perfect, luminous memory of rain and grass and the faces of people they will never see again, and that memory would grow more vivid and more beautiful with every passing year, precisely because it can never be tested against reality. The Earth in the traveler's mind would become more perfect than the real Earth ever was. It would become a paradise reconstructed from selected memories, stripped of every inconvenience and frustration and imperfection that the real Earth contained. It would become, in a word, mythological. And this is what Earth becomes at interstellar distance. A myth. Not a lie, not a fantasy, not a delusion. A myth in the original sense of the word. A story that carries meaning beyond its factual content. A narrative that shapes identity, guides values, and provides a sense of origin and purpose to a community that can no longer verify the story against the physical reality it describes. Earth becomes the ancestral homeland that the traveler's descendants will speak of in the same tones that ancient peoples used to describe their own lost origins, with reverence, with longing, and with the quiet understanding that the place described in the stories may no longer exist in the form the stories describe. Generations born on the ship will learn about Earth the way children learn about history, through texts, images, recordings, and the testimony of older generations who themselves never saw it firsthand. Each retelling will lose some fidelity and gain some embellishment. The blue of the oceans will become a deeper blue. The green of the forests will become a richer green. The faces of the founders will become nobler, wiser, more heroic than any real human face has ever been. Earth will be perfected by distance and time into something that no actual planet could ever live up to. And if, generations later, a descendant of the original crew were somehow to return to Earth, they would find a place that does not match the myth. A real planet with real flaws, real ugliness, real banality mixed in with the beauty. They would feel the disorientation of encountering the mundane reality behind a sacred story, and they might feel, for the first time, the full weight of what distance really took from them, not just a place. A version of a place that existed only in the space between memory and longing. This is the cost of leaving the solar system. Not the fuel expenditure, or the engineering challenges, or the radiation exposure, or the decades of travel time. The cost is the transformation of home from a living, breathing, operational reality into a beautiful, untouchable, powerless memory. A memory that cannot hear you when you call. A memory that cannot send help when you are hurt. A memory that cannot update itself to reflect what home has become while you were away. The most unsettling truth is not that Earth is small. Humans have known that Earth is small since the first photographs from space. It is not that Earth is fragile. Humans have understood fragility since the first nuclear weapon was detonated. It is not even that Earth is alone. The Fermi paradox has been teaching that lesson for decades. The most unsettling truth is that Earth is faithful. Earth does not stop caring about the traveler. Earth does not forget them. Earth does not choose to withhold its protection or withdraw its support. Earth would help if it could. Earth would rescue if distance allowed. Earth would speak comfort and offer guidance and send supplies and do every single thing that a home does for its people. If only the gap between stars were not so impossibly, relentlessly, unforgivingly wide. Earth is faithful, and faithfulness across interstellar distance is not enough. The most loving home in the universe cannot project that love across 4 light-years of vacuum in any form that arrives in time to matter. The most powerful civilization on the most beautiful planet in the most promising corner of the galaxy cannot reach a single person who has traveled beyond the edge of the sun's domain and entered the space between stars. That is what the title means. Earth means nothing once you leave the solar system. Not because Earth has no value, not because Earth has no beauty, not because the people on Earth have no love for the traveler or the traveler has no love for them. Earth means nothing in the way that a surgeon's skill means nothing to a patient on another continent with no transportation between them. The skill exists, the willingness exists, the love exists. The capacity to help exists. And none of it can cross the distance. All of it remains on the other side of a gap that physics will not let anything useful traverse quickly enough to matter. The traveler stands at a window. The stars outside are sharp, steady, and unfamiliar. None of them is the sun. None of them marks the location of home. The ship hums around them, recycling their air, maintaining their temperature, sustaining the thin envelope of habitability that is the only thing standing between them and the vacuum. Everything they need to survive in this moment is inside the hull around them. Everything they love is 4 light-years behind them, receding at a speed that will never bring it closer. They know Earth is there. They know the sun still burns, still holds its family of planets in their orbits, still warms the surface where billions of people live their lives without ever thinking about the edge of the solar system or what lies beyond it. They know that somewhere in the deep space network, a dish might still be pointed in their direction, listening for a signal that will never arrive at detectable strength. They know that someone, somewhere on Earth, might be thinking about them right now, wondering where they are, hoping they are safe, and they are safe for the moment. The ship is intact. The air is breathable. The crew is alive. But the safety comes from the ship, not from Earth. The air comes from the recyclers, not from the atmosphere. The warmth comes from the reactors, not from the sun. Everything that keeps them alive is local, self-contained, independent of the place they came from. Earth contributed the knowledge, the engineering, the training, the supplies. Earth built the Ark. But the Ark has sailed beyond the reach of the shipyard, and the shipyard cannot send another vessel in time to matter. This is not a tragedy. It is a transformation. The deepest, most radical transformation in the relationship between a species and its home that has ever occurred or ever could occur. The moment when Earth stops being the center of survival and becomes the center of memory. The moment when home stops being a place you can return to and becomes a place you carry inside you. The moment when the meaning of origin separates permanently from the power of origin, and the traveler discovers that they can love a place with every cell in their body while knowing that the place cannot lift a single finger to help them. Voyager 1 is still out there, drifting through interstellar space at roughly 11 miles per second, carrying its golden record, carrying the sounds of Earth, carrying greetings in 55 languages spoken by people who are mostly dead now. It is too far for its signal to reach much longer. Within a decade, the power will fail and the transmitter will go silent. The spacecraft will continue to drift, a small metal object in an incomprehensibly large darkness, carrying the memory of a planet that built it and launched it and listened to it for as long as listening was possible. When the signal stops, Earth will not forget Voyager. Engineers will note the date. Papers will be written. The trajectory will be tracked mathematically for as long as orbital mechanics remains a discipline. But no one will hear from Voyager again. No one will know whether the spacecraft is intact or shattered by a micrometeorite. No one will know if the golden record still plays, or if the copper disk has been abraded by interstellar dust into a smooth, featureless blank. Voyager will become what Earth becomes to the interstellar traveler. A known quantity in an unknown state. A thing that exists, provably, mathematically, but that cannot be verified, contacted, or reached. A memory encoded in physics and preserved by momentum, drifting through a darkness that does not care what it carries or where it came from. The stars do not know about Earth. The vacuum between them has no opinion about the small blue planet orbiting a modest yellow star in the outer arm of an ordinary spiral galaxy. The interstellar medium, the thin haze of hydrogen atoms drifting between the suns, does not recognize the significance of the place where Shakespeare wrote and Mozart composed, and a species of upright primates first looked at the sky and wondered if anyone else was looking back. Earth's significance is entirely local. It is the center of meaning for exactly one species on exactly one world, and that meaning does not project into the cosmos. It does not weaken with distance the way a signal weakens. It simply stops being relevant outside the system that generated it. The universe beyond the solar system is not hostile to Earth's meaning. It is indifferent to it. And indifference, at cosmic scale, is indistinguishable from erasure. That is the final truth this story has been building toward. Not that Earth is worthless, not that the traveler should stop caring, not that home is an illusion, or that love is pointless, or that human civilization is a joke told to an empty room. The final truth is simpler and harder than any of those. Earth is everything. And everything, past a certain distance, becomes almost nothing. Not because it changed, because you moved. And because the universe, for all its beauty and all its strangeness and all its billions of years of patient, silent construction, never promised that the things you love would be able to follow you wherever you go. The ship moves on. The stars drift past. The silence holds. And somewhere behind the traveler, too far to see, too faint to hear, too distant to reach, a pale blue dot continues to turn, carrying its freight of life and memory and meaning through the dark. Faithful, beautiful, precious, and powerless to help. That is what it means to leave the solar system. That is why Earth means nothing once you go. Not because it stops being home. Because home, at last, stops being enough.